Hello all, I want to take up some homework from section 4.4 before I move into 4.5. So I want to quickly do 3 questions from the homework. Hopefully you're not having too much trouble. Some of these are getting a little bit tricky. So I've got a solution here for one of the questions in the homework. On page 147 there are the 4 diagrams of a crate with 4 forces acting on it. If I look at the forces, I end up with the left-right forces. I've got a left force of 6 newtons and a right force of 5 newtons. So I end up with a left net force of 1.0 newtons. And then I've got 4 newtons up and 0.5 down. So that leaves me with 3.5 newtons up. And then if I do my Pythagorean theorem to solve for this side here, because I've got my right angle triangle here between my up, down, and left to right, I can now use my Pythagorean theorem to solve for F net, right? Square root of 1 plus the square root of square root of 1 squared plus 3.5 squared gives me a net force of 3.6 newtons. And then not only do I need to know that, but F net is also a vector quantity, so I need to actually determine the angle. So I'm going to look at my opposite side to the angle theta and my adjacent side, so katoa, and I end up with an angle of theta, which is 16 degrees, telling me the net force acting on this object is 3.6 newtons in a direction which is up and 16 degrees to the left. All right. Now, once you know that, the question's also asking me in the next part, what is the acceleration of the object? If I know that it's a 50 kilogram object, I can use my F net here equal to ma. I know my F net from the previous part of the question, 3.6 newtons. I know my mass is 50 kilograms, so I can solve for my acceleration, which is 0.070 meters per second squared, and the direction for acceleration is the same as the direction for the net force, which is up and 16 degrees to the left. All right, so that's question 44. Now that one's nice and easy because the forces are perpendicular to each other. I'm going to move down and look at question 48, which has 2 forces acting on a canoe. One is the force because of the river acting on the canoe. Okay, this is question 48 on page 147. The other is the fact that the river is flowing and pushing on the canoe also. Now we're told that the river is pushing on the canoe in the east direction, and the paddler has pointed the canoe north 38 degrees west and is also paddling the canoe in that direction. So as the paddler is paddling in that direction, we're also getting pushed to the west. All right, so it says use both the component and the trig methods to solve for this. I'm going to do the trig method for this one because the next one I'm going to use the component method. I will never ask you to do both. You can do whichever one you are most comfortable with, just so that you can be getting the answer the easiest way possible, because they're both right. Some people prefer the trig and some people prefer doing components. Okay, so the 2 forces acting are 15 newtons to the east, so I'm going to draw in a 15 newton east force, and then I'm going to have a paddler paddling north 38 degrees west. I'm going to draw my reference line in here. Let me just get rid of that. Move this down. My reference line here is my north line, and I'm going to go 38 degrees. 38 degrees. Oh, goodness me. .38 degrees to the west. So that second force is north 38 degrees west. Okay, so I've got 15 newtons here. I've got 22 newtons here, and I'm going to solve for this vector here, which is F net, which means the sum of the 2 forces. Now to solve for F net, I need to know if I can know 2 adjacent sides and the inside angle, I can use my cosine law. Well, I know my inside angle. If I know that this is 38 degrees in here, then I know what this angle is in here. It's 90 minus that 38, which is 52 degrees. Right? So now I can use my cosine law to say f net squared is equal to the two sides squared minus twice the product of the sides times the cosine of my 52 degree angle, and I'm getting an F net of 17.4 newtons. Okay. Now once I know F net, remember F net is also a vector quantity. So to solve for my direction, this is the force here. This is the net force right here. So I need to know what direction is that headed, and in order to do that, I need to know this angle in here. So my force will be east so many degrees, which I'm going to call theta. If this is going to work for me. Theta. Oh my goodness. Having no shortage of troubles here today with my stylus. Which does not want to do it. There we go. Theta. Theta degrees to the north. So east, theta degrees north. Now to do that, I'm going to use my sine law. So I know one angle, which is the 52, and I know its opposite side, which is now 17.4. So the sine of 52 divided by its opposite side, 17.4 newtons, is equal to the sine of the angle that I'm looking for, theta, divided by its opposite side, which is 22 newtons. And if I do that, I'm getting an angle theta, which is equal to 85 degrees. So now if I want to look for my F net, the F net is going to be equal to 17.4 newtons. We can probably just cut it to 17 newtons because of the sig digs. And the direction is going to be east 85 degrees north. You could also find that direction by looking north and turning 5 degrees to the east. Both are right because they're the same answer. That's for my F net, which is a vector quantity. Alright, so there's 48. So I'm now adding two vectors that are not perpendicular, and again, either using a cosine law or using my component method. Alright, let's turn the heat up here just a little bit, and let's go to question 49 on page 148. Come on. Alright, now, if I want to solve this one, I'm going to draw my free body diagram. It says two people are lifting a motor using ropes attached to the top of the motor. The motor hangs straight down, and gravity pulling it down is 1,600 newtons. One person is lifting with an 800 newton force, and the direction is look left and rotate 80 degrees up. The other person's on the other side of the motor and is pulling right 85 degrees up. We're told the mass of the motor, and we're asked to calculate its acceleration. It says use the component method. If I'm ever adding three vectors, I will always use the component method. If I'm adding two vectors, I will basically use the cos law and the sine law. But again, you could use the component method there too, whichever you prefer. So here's the sketch. Here's my motor, right? And it's being pulled 1,600 degrees down because of the planet. And it's 163, I don't know if I can get this in here, 163 newtons. Maybe I can make this bigger, it might work better. Oops. Alright, so if I look at the two other forces. One force says look left. Come on. And rotate 80 degrees up. And that's an 800 Newton force. The second person says look right, rotate 85 degrees up. And use 830 newtons. Okay, so what I have now are a number of forces acting in the left-right direction and along the up-down axis. All right, the left-right axis and the up-down axis. So I'm going to start by breaking down my two applied forces from the two people lifting the motor into their left-right component and their up-down component. All right, so let's start with the first vector here, which says look left, rotate 80 degrees up. It's probably less than 80, but there's 80 degrees. And I have 800 newtons. My force left, whoops, my force left is going to be 800 times the cosine of 80 degrees. And my force up is going to be equal to my hypotenuse, 800 times the sine of 80 degrees. Okay, which turns out the two of them are 139 newtons. That way. And this one is 788 newtons up. Okay, so there's my first vector, my first applied force. Now, if I look at my second applied force, let's move this up. My second applied force says look right, rotate 85 degrees up, and apply a force of 830 newtons. So my components are a right force and an up force. My force to the right is going to be equal to the hypotenuse, 830, times the cosine of 85 degrees. And my force up is going to be the hypotenuse, 830, times the sine of 85 degrees. Now, if I do my math, I get an up force of 827 newtons, and I get a right force of 72 newtons. So, if I look now at what I have left over, erase some of the junk I've got going on here. If I look at the up and down forces, I have 788 up here, 827 up here, and 1600 down here. So I'm going to add my, let's say plus is up. So I'm going to have 788 plus 827 plus negative 1600, and I end up with a net force up of 15 newtons. If I look at my force left-right, if I again choose, let's say I'm going to choose right as positive, I'm going to have a right force of 72 newtons, and I'm going to have a left force of 139 newtons. Right? So I'm going to have my net force is going to be plus 72 newtons plus negative 139 newtons, which equals negative 67 newtons, or, goodness me, or 67 newtons to the left. So I have 15 newtons up, 67 newtons to the left. Okay, let's take that information now and let's solve our answer. I have all those three forces that are acting. The planet plus the two individuals combined give me an upward force of 15 and give me a left force of 67 newtons. So my net force oh dear, come on. Is going to be square root of 15 squared plus 67 squared, or 69 newtons. Which makes sense, because again, if you look at your forces here, I have a 67 and a 15. It looks like this number here is going to be pretty close to 67 because of the small 15 on the one side. Now, I need to also know the direction, so I'm going to use my tan theta is equal to opposite divided by the adjacent, 67 over 15, giving me a theta, an angle for the direction of 77 degrees. So now, if I look at my Fnet as a vector quantity, it's 69 newtons in a direction which is up 77 degrees left. Look straight up and then rotate to the left. Now the question is also asking me for a distance traveled. To find the distance traveled by the motor over a period of 1.2 seconds, I obviously need to know the acceleration, which I can get from the Fnet. So if Fnet if I know it's a 163 kilogram motor, I can solve for the acceleration. 69 over 163, which is 0.42 meters per second squared. And I know the direction is up 77 degrees left. It doesn't really matter to me how you do your directions, with arrows or with letters. And now you can solve for delta D. Okay, Mr. Sinna's favorite equation, V1 delta T plus 1/2 A delta T squared. V1 is 0, 1/2 of 0.42 times the 1.2 seconds that are in the question, squared, and I'm getting a displacement of 0.30 meters. Right? And if it just asks for distance. If it asks for displacement, I'd have to say, okay, displacement now has this, and now it has the direction of up 77 left. Right? But again, notice it's not asking for that, so I'm not going to make this any harder for myself than I need to. All right, so there you go. So there is starting pretty easy with